All right, let's talk about where one of the players has three strategies in a game, and we're looking for the mixed Nash. Okay, notice I'm not asking you to do it where both players have three strategies. That's a lot more work. We saw the demonstration of that, the lizards, right? So we're not gonna play with that. Okay, but if one player has three strategies, that's actually totally doable. All right, so let me explain, but with what we have. So let me explain how you do it. Um, all right, so here's our first graph. Column can go left, center, right. Row can go up and down. So you want to start with the same way you normally would, but you want to start by finding the mixture for the person who's got two. So, and just to find it, but like we want to have the P mix here. So P equals percent up, and 1 minus P equals percent down, right? So that means if column goes left, the payoff is 2P plus 4 times 1 minus P. And let's simplify that out just a little bit. So this is 4 minus 2P. If column goes center, it's 5P plus 0 times 1 minus P. If column goes right, it's 3P plus 6 times 1 minus P, which is 6 minus 3P. Okay, I probably should start with this. Looking at these three values, like what's oftentimes going to happen is that the column player is only going to use two of their strategies because one of them is just better than the other one. Okay, and if we look at that, you can actually sort of see, right weakly dominates this, and I wish I'd given you an example where there wasn't a weakly dominant strategy. I think my next one doesn't have that, but I screwed up here. So we can assume that left is never going to get played by column, but that's a mistake. So sorry about that, but we'll figure it out. The math works out the same way. So once you've got those three values, you can't solve for all three of these equations to be equal at the same time. Doesn't work. So instead what we do is graph them. And that's the important half. So I've graphed 4 minus 2P, 5P, and 6 minus 3P. So you can see on the bottom, that's P. P goes from 0 to 1, and I'm going from 0 to 6 here. Okay? All right. The payoffs go from 0 to 6. Right? So this is the payoffs. So looking at this, I want you to think about what the best response. If I play 0.2, if P is being played 0.25, in other words, if row is playing up 25% of the time, what should column do? They should play this right here. They should play all right. Right is the best response right there. At 50%, right is still the best response. At 1, like right, then center's the best response. You know what's never the best response? Left. Left is never the best response to whatever row is, for a column, to whatever row is doing. That means column will never play left. That's it being dominated, right? Okay? Now, that's not always going to be true that one of them is never going to be the best response. Okay? But what I want you to think about here is to draw this and say, look, the best response line is the best they could do. So the best response goes like this. The lowest point on that best response is the best move for you. So right here, that's my best move. That's Row's. This is Row's mix. Okay? Is to play that. Right? That's their mixture, their Nash mix, I guess I should say. Is that lowest point on the top best response. And that's because that is you're doing the best you can. So this was a zero-sum game. I probably should have mentioned that. You're doing the best you could do based off of because they're doing the worst they can do. Okay? So we know Rose's mix, by the way, is 0.75 without doing anything. And we could also have done that if we eliminate left. So we go back here and we say, okay, left is just not happening. If I set these two equal to each other, if I set 5P equals 6 minus 3P, guess what? I get that P is equal to 0.75. So Row's mixture is 0.75. Now how do I get columns mix? Well, now that I've eliminated left, it's just like doing it normally would. So now Q is going to be percent center and 1 minus q equals percent right. So rho for payoff for rho, if rho goes up, it's 1 times q plus 3 times 1 minus q. So that's 3 minus 2q. If rho goes down, it's 6q plus 0 times 1 minus q. Set those equal. I got 3 minus 2q equals 6q. 3 equals 8q. Q equals 3/8. And we can find the payoffs, right, by plugging those back in. I never did it here, but 0.75 into 5, right? So rows, columns payoff equals 0.7 times 5 times 5. That's 3.75. And for row, we put 3/8 into 6q would be the easiest way to do it. That's 18/8, which is 2.25. Which makes sense. They should cancel out. Okay. So another version of this. This version is non-constant sum, and this time there's no dominated strategy, so it should be a little bit trickier to do, but the process is the same. So again, rows up is p, down is 1 minus p. So for column, the left payoff is 4 times p plus 3 times 1 minus p. Center payoff is equal to 5p plus 2 times 1 minus p. And the right payoff is 0p plus 4 times 1 minus p. Now, I'm looking at this, by the way, and I'm thinking, man, I would never go right. 0, 4 versus 4, 3, 5, 2. 0, 4 seems weak. So I'm assuming right's going to be the one eliminated. But let's find out. We can simplify these like right. So again, left is 3 plus p, right? Center is 3p plus 2. And right is 4 minus 4p. Hope that's right. Let's look at the next slide here. Look at the graph I made of it. So again, the best response overall is to go that green line is the best response line. It is the best column is going to do in response to the p. But this is the lowest point on there. This is the equilibrium. Okay? It's when right and left are out there. So center is going to be the one that's eliminated. We were wrong. Okay? And that's actually because center and left are fairly like similar in this case. But center is the one that's eliminated. So if I want to find exactly what that p is, I just set left and right equal to it. So 3 plus p equals 4 minus 4p. So that's 5p equals 1, p equals 0.2, and the expected payoff is equal to 3.2, right? Because I plug it right into the 3 plus p. Now I do it for right. So columns mix is q equals left percent 1 minus q equals right percent. So rho goes up, and that's equal to 2 q plus 6 times 1 minus q, and left rho goes down is equal to 5q plus 1 times 1 minus q. So this is 6 minus 4q is equal to 4q plus 1. 5 equals 8q. Q equals 5/8. And the expected payoff from that, right, we can plug it in right here for this one. Okay, is going to be 5 halves plus 1. Uh, 5 halves plus 1 is 3.5. Let's check these Q's again to see if they make sense. So row going P a bunch. Let's see if that makes sense. So row going down mostly. So if they go up, right's basically going to sit on left, or column's going to sit on left because 6, 0 is worthless for column. So column is really going to stay in left a lot, right? 5/8 in left, which means that row really wants to go down. It wants to go down 5/2, and they're even willing to sacrifice the occasional 1 because as long as column stays heavily on the left side. All right, that's it.